Typically, there are two reasons why you need to work on a bicycle's rear derailleur. Reason number one is that the shifter cable that runs through the derailleur and operates it stretches over time or lengthens over time, especially so in an indexing system of gear changing, which is the Shimano 105 an example of. So, periodically you need to come in and readjust the tension on the cable, or retension or pre-tension the cable, so that the gear changes in an indexing system can happen accurately and correctly. Reason number two for working on the derailleur, as is the case here, is that sometimes the shifter cable itself breaks, and this is my replacement cable that hasn't been cut to length yet, just for the purposes of this video. And replacing the cable involves lacing the cable in through the shifter, as well as rerouting the cable through the mechanical components of the derailleur. In this video I'll show you how this is done in terms of cable placement. I'll show you the parts that are involved, tools and supplies that are being used for getting this done, and most importantly, adjusting the tension on the cable or pre-tensioning the cable correctly for proper gear changes or accurate gear changes in an indexing system. So, because the cable has just been pre-tensioned, I'm going to shoot this video in a reverse order, so I can start with this geometric arrangement of how the indexing parts should work and line up, and then I'm going to take it apart, show you all of the bits and pieces and tools as we go along. Note, the chain is going to be noisy because it's completely dry. It has been cleaned and dry, it's not just dry due to negligence, it's just being cleaned, and I'm gonna have to lubricate it later because it runs a little noisily or excessively noisily. It's gonna be a little bit of a distractor. Don't worry about it. I cleaned it because I need to touch these components and point at it repeatedly, and just so I can shoot the video I wanted them clean. I also had a flat tire, had to handle the components, and so that also is a factor why the chain is unlubricated and runs slightly noisily. So I'm going to be also referring to, as I explain this indexing system, that the indexing bit is produced by the shifter. Inside the shifter, that in this case is mounted on the handlebar on the 5800 series, but many other brands and other shifter models and derailleur models also work along the same principles. So the barrel that's inside the shifter winds up a length of the shifter cable click by click. The clicks are the engagement of a ratchet between some gear teeth inside a barrel, inside a shifter that's again on the handlebar. So the internal operation of the shifter is producing the indexing, and the derailleur needs to be aligning to the indexing that the shifter produces. So the shifter shortens this shifter cable's length as it winds up on a barrel one click at a time. Those clicks are not only that it's produced, the click sound is produced by the ratchet, but the distances between the gear teeth in which or in between which the ratchet engages, those distances between the gear teeth in the shifter on the handlebar, those pitch distances are the preset distances by which the cable is being shortened. As this cable is being shortened, it should produce a shortening of this, compressing the spring inside the derailleur here, and it should, a compressing spring should move the derailleur further and further in. That means, let me just reposition the camera here into this place here, that not only, just give me a sec here, that not only the chain should run in a straight line through one of the sprockets on the cassette set, with the chain running straight through the sprocket, through the upper jockey wheel or pulley wheel and the lower one in a straight line, and you should be able to put a ruler on this, but their alignment is what's dictated by the tension on the cable. So if there's too much tension on the cable, it's going to be pulling the derailleur into a position that's in between, that these two wheels, the upper and lower jockey wheel, are in between two of the any of the sprockets above it on the cassette set. So if the derailleur is in an in-between position, it's going to be causing a noisy run on the chain, an inefficient run on the chain. The side walls of the plates of the chain will be rubbing against the next sprocket above or below, whichever the case, whether you're upshifting or downshifting. So there shouldn't be an in-between position on the derailleur's jockey wheels. Okay, it should be pulled into a position of perfect alignment where the center line of the chain links line up with the exact center line of the gear teeth on the one of the sprockets, line up with the center line of the jockey wheels little teeth, the upper and both the lower. Okay, I hope that makes sense in terms of alignment. That's what we're looking for. So if the cable is tensioned properly, a shortening of the cable at the shifter when it's wound up on the barrel should shorten it just enough to run this distance from center line of the teeth to the next center line of the next teeth, either upshifting or downshifting. So how this looks like or sounds like is when we're pedaling ahead, one click on the shifter should produce one gear change on the sprockets like so, with the chain running silently just like this with minimal noise, and this is the dry chain. One more click should produce one more shift up, one more shift. So downshifts have lesser sound of a click. That's one down, one more down, and one more down. So because pre-tensioned cable, or the condition of this is especially visible down here at the lowest or the smallest sprocket teeth here at the highest gears. So this is where you can see whether the tensioning has been done. Of course you should check the full range of gears, make sure that indexing is done properly through the entire range of gear teeth, but especially so, or especially visible in the lowest set of teeth. So come on out here again. I'm going to be messing with the cable tensioner. So let me just one shift up. Let me just run up, see, 3 shifts up, 3 shifts down. It's going up and down flawlessly. Alright, so now I'm going to relax this cable excessively, or as much as I can. There. Let's see what difference this makes. One click now does not produce one shift because there's too much slack in the cable. The cable did get shortened. The spring in the derailleur is being compressed, but all it achieved is that it moved the jockey wheels from being aligned with the first sprocket there to an in-between position where the chain runs somewhat more noisily than before. Somewhat. So let's see one more click, see if a second click causes enough spring compression in the derailleur to produce a shift. Yes, it does, but of course it's not ideal. The number of downshift clicks, that's 1, that's 2, and I had a third one that relaxes the derailleur just a touch more, so it's not working precisely. Let's shift up 1 and nothing happens. So that's when there is excessive slack on the cable, and that's 1 downshift and nothing happens. It's neither changing gears up nor changing gears down, and if anything it just becomes more noisy. So that's less noisy, and that's more noisy. Alright, if the cable is excessively tensioned, which is the other way around, and I don't know, let's give it 5 turns, whatever, something like that. Let's see what happens now. It's gonna be excessively noisy again, and it does produce an upshift, but you can also hear it also wants to shift almost up on its own. You can see the jockey wheels are running with some glitches and excessive noise because there's too much tension on the cable. It almost shifts to the next gear up, and this excessive noise is completely inefficient and causes extra wear on the chain and is absolutely unnecessary. This is also an example of a badly adjusted or badly pre-tensioned cable. It does shift up, but it keeps being noisy because the upper and lower jockey wheels are again in an in-between position. They are not really lining up with the sprockets center line to center line to center line accurately enough. The chain does connect everything, but it's not aligned center line to center line. Okay, I hope that makes sense. It also shifts down, but it runs noisily and it does not shift down to the lowest gear here. You can kind of see there's the chain just doesn't want to jump down to the lowest sprocket there because the cable, the shifter cable, cannot relax enough. So let's take it apart. Taking out the cable needs a single 4mm hex key or Allen key. That's also how the cable is going to be clamped in place. It does not need 10 turns to take out the cable, but I want to back it out enough not to lose the washer, but to show you some detail here. So the cable goes underneath the washer, between the washer and the derailleur's body. Let me just rotate this one further out. The cable also goes into a groove. You can see the groove between my index and thumbnail there. That's where the cable should be placed, right there. The place of this groove is indicated also by a small white arrow by Shimano there, or a small white triangle, I don't know, depending on your philosophical bent. There it is by my thumbnail there, indicating the place of this groove. So the torque specification of this bolt I don't remember, and I don't want to come up with an imaginary number, but it's included in this video's description. Whatever it is, it cannot be adjusted or cannot be really properly set with a tool like this. It can be eyeballed in a pinch, but you ideally need a torque wrench that can be set to the specified torque. So it is in inch pounds. Maximum inch pounds on this particular model is about 240 inch pounds and 24 Newton meters. So whatever the specification on that bolt is, depending on your make and model, you have to set it with a torque wrench ideally. From here on, the cable just comes out through the tensioner just like so, and that's all there is to it. So over tightening this bolt is completely unnecessary. This just clamps down on the shifter cable and holds it by friction. It might develop a kink, but it kinda, I'm not saying it shouldn't. You can see how the edges of the washer compressed the wires in this cable. That's okay, but on my old cable, which I have here for a deterrent example here, this is how the manufacturer tightened this bolt. You can see that the wires are compressed to a point where they also break, which of course snag the clothes and cause other inconvenience. So that this is completely unnecessary that the bolt be tightened to this degree. The cable could be cut to length once you're done with adjusting this tension here, and where this tension adjustment gets started is fairly straightforward. Just run the cable through like so and pull it tight just like so with your hand, bracing it against a little bit on the derailleur's body like so. Run it through the groove. It will line up on its own. It's been designed reasonably, so you can tighten this bolt with just a simple tool like this, just to hold it in place, so you have both hands available for getting your torque wrench. It doesn't need to be pulled with a pair of pliers or whatever. The cable is coated otherwise, so plier jaw marks will just mar the coating. Unnecessary. Of course, if you have slippery hands, whatever, Of course, with a small pliers, yeah, sure, pull on it, but compressing the spring in the derailleur with excessive yanking on the cable is gonna be defeating the purpose. So just take out the slack, just this much is close enough. You have to start with a little bit of a slack on it in order for you to find the position where the cable is neither too slack nor there is too much tension on it. So the cable can be cut with mechanical means, like very simple wire cutter such as an electrician would have, and just cut the wire, and then the end of the cable, wherever it's being cut, to keep the wires from fraying and unraveling, which is kinda can be seen how it looks like on my old cable, which was this is not the cable's end, this is where it broke inside the shifter drum. So but if your cable end that you cut looks like this, it's gonna snag your clothes and it's gonna be a source of nuisance. It's gonna unravel, and it just is ugly. So when you cut it, crimp it or hold the end of the wires together with a small aluminum ferrule like this, which is a small sleeve like so, looking like this. This one is unused, this one is an older one. I can still reuse it, put the cable in it because it's not broken or not bent beyond recognition, and these pieces just get crimped on the cut end of the cable wherever it ends, and just deform it gently with a pair of pliers to keep the end of the cable from fraying or unraveling. One plastic component that centers the cable here as it exits the jacketing is this one. This one has a long extension. Let me just pull it all off. So this one has a long extension. Your Shimano, I think in this case, recommends one with no extension, just a piece of plastic like so that wraps the cable jacketing and just has a hole, nothing else. Centers again the shifter cable inside the jacketing, just so there is no friction or less friction and less wear on the cable. The cable jacketing is made of, other than the vinyl coating, it's a wire. Let me just get you a nice picture of it there. It's made of some wires, so ideally the shifter cable's wire shouldn't rub against the wire of the jacketing. That's why centering the cable there with the plastic fitting is important. I hope that makes sense. And at this point, the lower end of the cable, because it's kind of close to the wheel and it gets wet here all the time, some generous amount of lubrication or even a blob of grease here would be probably helpful in extending the life of the cable and lowering the friction here, because this is prone to be contaminated with muck that's thrown up here by the wheel. So that's the cable, and if I can take out this component here quickly, you can see this metal colored or shiny part is extending through the black one. Put a finger on it because it's spring loaded and you don't want to lose it, or the spring. So these are the three components that make this fine adjuster. It's a thread with a fine thread pitch on this one, and it should be free and clear of any obstructions or dirt. Should look like this. The spring goes around it, and this is just a piece of plastic that kind of holds it together. Easier to grip it this way. So when you put it into the derailleur's body, you should compress it with your index finger as this one is being threaded in place. Try not to cross thread it. The derailleur is $60, completely unnecessary to ruin it or ruin the thread in it. There, that's how this looks like. When you put the cable in, start with the fine adjuster, the spring in it completely compressed like this. I'm gonna grab this part of the cable here, lace it through. It's a dry fit, so it doesn't have a grease blob or any kind of lubricant on it, so I'm just gonna show you how the components go together yet again. There, through the groove, there and tighten the bolt like so. In this configuration you leave a little bit of a slack so you have time, or you have space here to tension it as you get to it, or you can relax it a little bit. So I usually like starting with the adjuster fully compressed in this position. Alright, now I'm just gonna take it apart because I'm ready to lubricate it with grease and re-lubricate the chain and everything. So that's how this looks like. Finding this position here where it's pre-tensioned just correctly takes a little bit of trial and error and a little bit of playing. Do this with the bicycle hanging vertically like this. If you try to vertically, as in wheels down, if you try to flip the bicycle upside down, this the weight of the derailleur and whatever relaxes differently and will be not really producing a useful result that way if the bicycle is upside down. So it should be adjusted this way, rubber side down. So that's basically what I wanted to share with you about the indexing system, how this fine adjusting and cable tensioning works together for proper indexing of the gears. Thank you very much for watching.